Let's practice a little bit more. We have a -3 to an odd power to the 3. So we know we're going to have a negative. 3 times 3 is 9, times 3 is 27. The m and the n both have understood exponents of 1. 1 times 3 is 3, and 1 times 3 is still 3. All of this is raised to the 0 power, and anything to the 0 power is just a 1. This, we're going to essentially distribute that -2 exponent through everything. So we have 6 to the -2. K, 3 times a -2 is going to give me a -6. Well, the negative means it needs to be in the other place. So that's going to give me 1 over 6 squared, k to the 6th. 6 squared is 36, k to the 6th. Here, we have a positive exponent. So we have 5 squared, x to the -6th. Well, the 5 squared is going to stay as 25, but the -6 goes to the denominator now as a positive 6 exponent. Here, we can simply distribute the 4 exponent to both numerator and denominator. Now 3 to the 4th is small enough that you can go ahead and expand that out. 3 times 3 is 9, times 3 is 27, times 3 is 81. This negative means both of these things are in the opposite place, so we need to change that to a j over k. Now we lose our negative, and so it's just j cubed over k cubed. We have a positive exponent, so we're not going to rearrange numerator and denominator pieces here because all of our exponents are positive. We need 2 cubed. Well, 2 times 2 is 4, times 2 is 8. X cubed, 2 times 3 is 6 over z cubed. And here, we're going to go ahead and move this negative exponent first. 4 over p cubed q squared, which is tricky to say. Now we can distribute that squared exponent. 4 times 4 is 16. P cubed squared is p to the 6th. Q squared squared is q to the 4th. Let's just expand it a little bit more. We know that 3 to the 4th power is going to be 81. X to the 2 times 4 is 8. Y to the 4 times 1 is 4. Times 2 times 3 is 8. X cubed y to the 6th. Now, if you know 81 times 8 off the top of your head, great. You can either calculate it off to the side or use the Desmos calculator, but that'll give you 648. 8 x's multiplied by 3 x's gives us 11 x's. 4 and 6 y's gives us 10y, or y to the 10th, excuse me. Here we have x to the 3 times 4, which is 12, times x to the -2 times 5, which is a -10, over x. 6 times 5 is 30. We can either say this comes down, or what's actually easier in this case is a 12 plus a -10, which gives us x to the 2nd over x to the 30th. Now, you can write this either as 2 minus 30, which is x to the -28, or 1 over x to the 28. When you're practicing, look to see what format it needs to be in. Obviously, if it's a multiple choice question, you won't have both choices unless it's select more than one. Finally, for part C, we're squaring all of this. 2 squared is 4, x squared is x squared, y squared squared is y to the 4th, x to the 6th, y to the -4th, times, I'm going to go ahead and flip this, that's what that negative says I would need to do, x cubed y to the negative 1 over 12xy cubed. Now let's clean up the individual insides. This is going to give me, well, the y to the fourth over y to the negative fourth does not cancel. The y to the negative fourth comes to the top. That gives me a 4, y to the eighth, 6 and 2 would give me an x to the fourth in the denominator, times x cubed over x gives me an x squared, 12y to the fourth. Multiplying those gives me a 4x squared y to the eighth over x to the fourth. Fourth, and a 12y to the fourth. 4 over 12 is the same thing as 1 over 3. X squared over x to the fourth puts the x squared in the denominator, and a y to the fourth in the numerator. Now, I went through that one kind of quickly so that you can see the answer. Take your time and go through this example on your own and make sure you come up with the same answer. So scientific notation is a way of making use of this to write particularly large numbers or small numbers. For proper scientific notation, you have one particular rule that you look at. You have exactly one non-zero digit to the left of the decimal. What that means is the way this is written, our decimal point is here. We need to move it from here to here. And so we do that by moving it 1, 2, 3, 4 ways, 4 spaces. That is what? Well, since we use a decimal system, that is a 10 to the fourth. So it becomes a 3.7 times 10 to the fourth, because 10 to the fourth is 10,000. And so we have 3.7 10,000ths. This way, we need to move it to the right. Now, since this number is less than 1, what we end up with is a 5.2. This was a positive exponent. Since it's less than 1, we end up with a negative exponent. We moved it 1, 2, 3 times to the right. What this is essentially saying is this is 5.2 divided by 10 to the third, or 5.2 divided by 1,000. And oftentimes you will hear this spoken as 5 and 2 thousandths, or 52 10,000ths. In this case, if we're going to expand it, we move it 3 decimal places to the right. So we are at 62. We need to move it 1, 2, 3. So this is 6.2 thousand, 6,200. This we move to the left. We have 8.9, and we need to move it 1, 2. So we have a negative 0.089. I usually recommend put that 0 in front of the decimal place when you're using expanded form so you don't lose it. If you're multiplying or dividing with scientific notation, it becomes very easy. First, we're going to multiply and divide, then we're going to write it in expanded form. Negative 4 times 2 is a negative 8 times 10, well, 10 to the fifth and 10 to the negative 7th. As we were doing a minute ago with our exponents, you simply add them. That's a negative 2. So now I have my 8, and there's my decimal point, 1, 2. Okay, so a negative 0.08. In this case, we can, 9 divided by 3 is 3. 3 minus a negative 2 is 3 plus 2, which is 5. We have to move our decimal place 1, 2, 3, 4, 5 times to the right. It's 300,000.